Somewhere over the American Northwest, on a gray December morning in 2020, a Boeing test pilot experienced something that had no business happening on a mature aircraft program. No warning light, no system alert, no input from anyone in the cockpit. The nose just moved, up, then down, up again, violently, repeatedly. The crew fought the controls while engineers on the ground stared at their data feeds in silence, the kind of silence that tells you everyone in the room already understands what they're looking at and nobody wants to say it out loud. This was the 777X, Boeing's flagship comeback story, the program that was supposed to silence every critic, rebuild airline confidence, and prove that the company responsible for some of the most iconic machines in aviation history still had the engineering firepower to lead the industry. Instead, it became something else entirely. To grasp the full weight of what went wrong, you need to go back to a moment when Boeing could do no wrong. Back to when the people inside that Everett factory genuinely believed they were building the future. And they were right. Because this isn't a story about one bad component or one bad decision. It's a story about institutional decline, told through metal and rivets and missed deadlines. And by the end of it, you'll understand not just what broke, but why it broke, and whether Boeing has any real path back from here. There was a period not so long ago when Boeing didn't just make airplanes. It set the terms for what airplanes were supposed to be. The late 1980s presented the company with a puzzle. Its 767 was a dependable workhorse, perfectly suited for transatlantic hops and medium-density routes, but it ran out of range before reaching the far corners of the world. The 747, at the other end of the spectrum, could theoretically land anywhere on the planet, but its economics only held together if you were moving enormous volumes of passengers. Airlines operating thinner, long-range routes were stuck in the middle with no ideal tool for the job. Rather than designing the aircraft they thought airlines should want, they asked airlines what they actually needed, and they meant it. Carriers from around the world were brought into the development process at the earliest conceptual stages, not as consultants reviewing finished drawings, but as genuine contributors shaping the aircraft from the ground up. When Cathay Pacific made the case for a wider cabin cross-section, Boeing's engineers didn't push back. They widened the fuselage. When United Airlines specified precise cargo door requirements, those specifications went into the design. This wasn't customer service, it was collaborative engineering at a level the commercial aviation industry had rarely seen. The aircraft that emerged from this process was extraordinary by any measure. The 777 was the first commercial jet ever designed entirely through computer modeling, which eliminated the costly physical mock-up stage and compressed development timelines significantly. Its fly-by-wire flight controls brought a level of precision and adaptability that its previous generation couldn't match. And the engines hanging beneath its wings were, at the time of entry into service, the most powerful turbofans ever bolted to a commercial aircraft. From program launch in 1990 to the moment the first production 777 was handed over to United Airlines in 1995, 5 years and change. In an industry where major aircraft programs routinely stretch for a decade or more, this was treated almost as a miracle of organizational execution. The aircraft went on to earn its commercial success many times over. The 777-300R variant, capable of connecting virtually any 2 cities on Earth while carrying between 350 and 400 passengers, became so capable that airlines started pulling their 777s out of service on routes where the older jet was simply too large to justify. The 777 had made the world's most iconic wide-body aircraft feel redundant. That is how dominant it became. Boeing, during those years, was a company that knew exactly who it was. The first real challenge to the 777's market supremacy arrived in 2006 when Airbus formally launched its A350 program. Airbus had initially planned something modest, an updated A330 with revised engines and a reshaped wing. But when airlines responded with polite disinterest, it became clear that a light refresh of a 30-year-old fuselage lineage wasn't what the market was looking for. Airbus went back to the drawing board and committed to something genuinely new: an all-composite fuselage, cutting-edge systems architecture, modern aerodynamics throughout, a clean sheet. The smaller A350-900 variant didn't particularly threaten Boeing's position, but the A350-1000, the large, long-range version Airbus was developing explicitly to challenge the 777-300R, was a different matter. Airbus had positioned it with precision: better fuel burn, lower maintenance burden, the operational appeal of newer technology. It was aimed directly at Boeing's most profitable segment, and airlines were listening. Boeing's situation in the early 2010s made a straightforward response nearly impossible. The 777 MAX program had just been launched, consuming engineering attention across the company. The 780 Dreamliner, after suffering through years of delays and a highly publicized global grounding triggered by battery fires, had finally entered service. But managing its ongoing teething problems was an ongoing drain on resources. A stretched 780-10 variant was also in development simultaneously. Launching an entirely new aircraft to counter the A350-1000 would have taken a decade and required investment that Boeing simply couldn't mobilize given everything else it was managing. So the company chose a different path: leverage the existing 777, new engines, redesigned wings, updated cabin, keep the proven fuselage, move fast enough to get to market before Airbus could establish a dominant foothold. In September 2013, the 777X program was officially launched. Emirates and Lufthansa signed on as launch customers. Entry into service was penciled in for 2020. The plan looked achievable. It wasn't. The 777X was never designed to be a simple derivative. The decisions Boeing made in pursuit of performance and market competitiveness stacked complexity upon complexity in ways that the program's original schedule didn't fully account for. Start with the wings. The 777X required a wingspan significantly larger than its predecessor to deliver the aerodynamic efficiency Boeing had promised in its sales presentations. The problem was this wingspan, if deployed in full, would push the aircraft into a larger airport gate category, meaning airlines would face higher handling fees, reduced route flexibility, and operational constraints that would undermine much of the economic case for buying it in the first place. Boeing's solution was the folding wingtip. When the aircraft is airborne, the full span is deployed. On the ground, the outer sections fold upward, bringing the overall footprint back within standard gate dimensions. It was a clever answer to a genuine operational constraint. But Boeing required Boeing to construct a dedicated new composite wing manufacturing facility in Everett, a capital investment exceeding $1 billion, and to develop entirely new manufacturing expertise for structures at this scale. The facility was deliberately built larger than the 777X program alone required, with Boeing anticipating that it would eventually support a proposed new mid-market aircraft program serving the gap between the 737 and 787. That program was later quietly shelved in the aftermath of the 737 MAX crisis. The oversized facility remained, a very expensive monument to plans that never materialized. Meanwhile, Boeing's attempts to modernize fuselage assembly through robotics ended in a costly failure. The FAUB program, Fuselage Automated Upright Build, promised to replace much of the manual labor involved in riveting fuselage panels together with automated systems. In theory, robots would deliver better consistency, faster cycle times, and lower labor costs. In practice, the automated systems introduced defect rates that required human workers to perform rework at levels that negated the intended efficiency gains. For years, Boeing persisted with the program, absorbing the costs and delays in hopes that refinement would eventually make it viable. In late 2019, they abandoned it entirely. The write-off represented years of lost time during a period when the program could not fall further behind. By the spring of 2019, the 777X was already running more than a year past its original milestones. What came next made that look minor by comparison. 6 minutes after takeoff from Addis Ababa on March 10, 2019, Ethiopian Airlines Flight 302 went down. 157 people were killed. It was the second fatal 777 MAX accident in less than 5 months. What followed reshaped American aviation oversight more fundamentally than anything since the creation of the FAA itself. The investigations into both MAX accidents revealed that Boeing had been operating within a certification framework that placed extraordinary trust in the company's own judgment. Boeing employees carrying FAA authorization had been conducting much of the validation work that regulators would normally perform independently. The system assumed that Boeing's engineers would elevate safety compliance above schedule pressure. In the case of the MAX, that assumption proved fatally wrong. The FAA's response was extensive and immediate. Delegated authority was curtailed sharply. Agency personnel were now required to be physically present during critical test activities, reviewing data and validating findings directly rather than accepting Boeing's self-reported results. Certification timelines would be driven by regulatory satisfaction, not Boeing's internal project schedules. For a 777X program already struggling with structural test failures, a fuselage rupture during pressurization testing in September 2019 had generated alarming headlines, even if the technical reality was more nuanced than the coverage suggested. This shift in FAA posture meant that every remaining milestone would require more time, more documentation, and more independent verification than anything Boeing had experienced in recent memory. Then came December 2020 and the uncommanded pitch event, an incident that might once have been managed quietly through internal technical processes, instead triggered a formal and very public FAA rebuke. European regulators, watching from across the Atlantic, simultaneously decided they were no longer willing to accept FAA certifications at face value and launched their own independent review processes. Boeing's decision to redirect 777X engineering resources toward the still struggling MAX 7 and MAX 10 certification efforts, a rational triage decision given the financial pressure those programs were under, effectively put the 777X into suspended animation for a period measured in years rather than months. July 2024, the FAA granted Type Inspection Authorization. After 4.5 years of certification limbo, agency test pilots could finally begin their own evaluation flights. For 6 weeks, the program made real progress. Multiple sorties per day, systems performing as intended, a delivery timeline measured in months, not years, suddenly felt credible. Emirates, Lufthansa, and Qatar Airways, carriers that had restructured fleet planning around 777X deliveries that kept failing to materialize, allowed themselves cautious optimism. On August 15th, a test aircraft completed a 5.5-hour evaluation flight and landed at Kona in Hawaii. The post-flight walkaround found a failed thrust link. These are the titanium structural components that physically connect each engine to its pylon and through the pylon to the rest of the airframe. Their job is deceptively unglamorous. Take the thrust produced by an engine generating 110,000 pounds of force and transfer it smoothly into the aircraft structure. Under normal conditions, this is a steady, predictable load. Under abnormal conditions, an engine flame out at full thrust, A bird strike causing violent oscillations and asymmetric power loss during takeoff rotation, the loads become dynamic, complex, and capable of cycling rapidly between extremes. The 777X design specifies 2 thrust links per engine, oriented at different angles so that a failure of one cannot bring down the engine. When the Hawaii aircraft's link failed, the second held. Catastrophe was avoided by the redundancy Boeing had built in. But fleet-wide inspections revealed that the failure wasn't an isolated anomaly. Additional cracks appeared across multiple test aircraft. The pattern pointed not to a single defective part, but to a systemic design issue. And because Boeing, not General Electric, designed the thrust link architecture, the responsibility for resolving it sat entirely with Boeing's engineering teams. Another grounding, more redesign, more lost months. By January 2026, a separate durability concern had been identified in the GE9X engine itself during routine inspections. Boeing and GE are working through it. The first delivery, once promised for 2020, is currently targeting mid-2027, with meaningful asterisks attached even to that date. 13 years. That's how long the 777X has been in development, against an original target of 7. The original 777, clean sheet design, no proven platform to build from, first time Boeing had done any of this, took just over 5. The financial damage is real. Billions in cost overruns, compensation payments to airlines holding delivery positions, idle capacity in facilities built for programs that never launched. Boeing's credit rating has been cut to junk territory at various points during this period. The human cost, the 346 people who died in the MAX crashes, which set many of these cascading failures in motion, cannot be expressed in program budgets at all. But the deepest damage is harder to quantify. It lives in the gap between what Boeing once was and what it currently demonstrates itself to be. The original 777 was built by a company that listened to its customers, trusted its engineers to solve problems without cutting corners on verification, maintained the kind of relationship with its regulators that allowed certification to proceed efficiently, and delivered what it promised on the timeline it promised. Every one of those capabilities has been degraded, some through explicit decisions that seemed rational in isolation, some through gradual cultural drift that no single executive chose, but that the organization's incentive structures quietly encouraged for years. The 777X is what you get when those capabilities erode far enough. Not a conspiracy or a single catastrophic failure of judgment, but the accumulated weight of 1,000 smaller compromises finally becoming too heavy to hide. Whether Boeing can reverse this is an open question. The engineering problems on the 777X are solvable. They're being solved, slowly. The organizational problems are something else entirely. Rebuilding the culture that produced the original 777 isn't a matter of hiring the right consultants or issuing the right internal memos. It requires sustained commitment to the kind of rigorous, patient, unglamorous work that produces genuinely safe and reliable aircraft. Boeing did that work once. The original 777 is the proof. The 777X, after 13 years and counting, is the proof of what happens when an organization forgets how.